Anyway, that was fun. So now we have a quiz, and we'll use the Socrative software. Has very little to do with Socrates. So let's everybody get their app out. Anybody not have it? Why? What's wrong? What?
My phone is right off.
You can't access it now? Okay. In that case, you can write it on a piece of paper.
Actually, I also don't have it.
What?
I also don't have it.
You don't have it? You can't download it? You can't access it?
Maybe.
Yeah, you can get it on the App Store or on Google. Okay. So if you didn't do it this time, you can write it on a piece of paper. Okay, so we're going to have 3 questions. And let me set it up. First one. Okay, this is question 1. Okay, so you have to go to this room number, which is something Y. Okay, 527048. Okay, so it asks you for a room number, and you have to go to that, 527048. Now, yeah, what? Nobody had, it says, okay, good. So we have 0 out of 22 students have answered. That's good, because I haven't given the question yet. Okay, has everyone gotten there? Anybody not there yet? Except for the 2 people that don't, or 2 or 3 people that don't have the app? All right, let me give you the question, and you will... Everyone get this room number? Okay. I'll write it on the board just in case. 527048. Okay. All right, now I'll give you the question, which is somewhere. Where did it go? Okay. So there are only 4. Oh, whoops. That won't work. Sorry, 1 second. Give me a second. There's only 4. No. Just 1 second. Just 1 second, please. Okay, so there's only 4 possible answers, so you don't put anything for the 5th one. Okay, so go ahead and try to give the answer. So this would be A, this would be B, this would be C, and this would be D, so you choose one.
Sir, can you zoom into the question?
Can I what?
Zoom in.
So it says, limit as x goes to -3. Not talking. Okay. All right, let's go to the next question. Okay, next one is another one. Okay. And the next question is here. Now there are five possible answers. So this says the limit as x goes to 0. And then the last one. Okay. Last one is here. The limit as x goes to 3, and there's a little plus there, which I usually write with a plus up at the top, not right at the same level. So it's usually written like this. But maybe in Kant he writes it like that. Okay? Okay. So we had our quiz on Khan Academy. And what were the answers? Oh, sorry, before the answers, can the people who wrote it on paper please bring their paper up here? And your name is on there? Name is on there. Okay, so, yeah, please. Just give me it. As it is, it's okay. I'll figure out who you are. Okay, so from now on, please have downloaded Socrative. Okay. Okay, so what were the answers? They were all the same. What were they? This one. You might be tempted to say the answer is infinity, but the best answer here is the limit does not exist. Okay? Infinity, when we say infinity, it also means that it doesn't exist. Okay? Here, same question basically, at 0, it's just the same question really. So again, the answer is the same. And finally, the last one. It's not exactly the same question, but pretty close. This means as x goes to 3 only from the right. So if you're only looking from the right, it goes to negative infinity. Again, that really means the limit doesn't exist. Okay? So I hope that these were all covered in Khan Academy. And okay, so today we're going to talk about derivatives or calculus, and we studied limits in order to do this problem. So like I said, the limit is just a tool. So the original problem came from an example like this. Now, we're in business, you're not concerned with dropping balls, but the original problem came from dropping balls. So let's look at that one, and then we can see how you can also apply it in various business scenarios as well. But let's suppose that you have a ball and you drop it. And let's call the distance d. So d is distance that it falls. Ball falls. Okay. And I'm going to call it positive. So if it falls to here, that's like maybe positive 10 meters. Okay? You might call this negative, but just to make it simple, I'm going to call that a positive number. Okay? And now obviously, or pretty obviously, d, what does that mean?
What?
D is a function of t. What does that mean? Means, another word for function is depends on. So why would I say that d depends on t? Because obviously the distance that it's fallen depends on the time. So that's obvious. Now, what's the correct function for that? Is it, 5t? Or is it 5t plus 3 or whatever? Well, we're going to say that the correct answer is 10t squared. Okay, now the better answer is 9.8 t squared, and that means meters. Yeah. So 9.8 t squared meters. But I don't want to deal with 9.8, so I'm just going to approximate that as 10. And so what does that mean? So that means that when f is 0, what does f of 0 mean, by the way? It means when t equals 0. Right? When t equals 0, d is equal to what? Well, if you look at this formula, when t equals 0, d is equal to what? 0. So that makes sense. That means at the beginning, the distance that it's fallen is 0. Right? Right? We said d means how far it's fallen, so this is d. How far it's fallen. Okay, so how about when t is equal to 1? What does it mean? Well, when I put in t here, I get what? T is equal to 10. But that seems plausible. It's 1 second, it's fallen to a distance of 10 meters. Okay, and when t equals 2, what does that mean? What does that give us? So that's 2 squared is 4, so d is 40. So that sounds also plausible in the sense that in the first second it only fell to 10 meters, but by the second it had fallen to 40 meters. Well, that makes kind of sense. That means in the first second it fell 10 meters, but in the second second it fell 30 meters. So it's going faster, so it falls further. So it's not counterintuitive. It seems to align itself with our intuition. Okay, and let's just do one more. If t equals 3, where is it? According to that formula. If that formula was correct, which it actually isn't, but if it was, it would give us d is equal to what? 90. So how far did it fall in the first second? 10 meters. How far did it fall during the second second? 30 meters. How far did it fall in the third second? 50 meters. So it must be going faster and faster. Right? So that makes sense. So, okay. So we assume that this is correct, but even though it's not. Okay? Okay. Now, I can ask you the question we want to focus on, which is what's the average speed? Or speed, remember, what's the definition of speed? If you give me a speed when you're driving in your car, you might say what? I'm going, what? 100, what? Kilometers per hour. So 100, for example, 100 kilometers per hour. By the way, what does that mean? That means if you went 100 kilometers per hour for 1 hour, how far would you have gone? 100 kilometers, right? That's what it means, right? So this is a rate, right? Obviously it's a rate, right? We call it a rate of change. Rate of change. Other examples of rates of change having nothing to do with speed or balls might